Hello everyone, welcome to the course Computer Integrated Manufacturing. In this lecture, I like to bring you to the laboratory demonstration on the CAM, Computer Aided Manufacturing. We had discussed CAD, we had discussed a lot of theory on CAD, CAM, Computer Aided Part Programming. You have seen already how does the part programming happens in laboratory or on the machine. First we will see the Power Mill software here. Power Mill is one of the CAM softwares. Then we will see how does the machine runs, how does the software interfaces with the machine in the next lecture. So, this is the interface for the Power Mill software. Again recalling the difference between CNC and NC machine was that in NC machines what we used was the numerical control. Numerical control was nothing but using magnetic tape or the punched card to control the machine. Now, when comes the computer, computer makes it CNC, computer numerical control, in which the data can be recorded in a computer, data can be put in a CD or a DVD, or it was the floppy disk also before. Now, it can be put in a pen drive or through internet as well, through the cloud as well. The data can be fetched and put in the software, and it can be from the software sent to the machine for the manufacturing. In NC code there are certain limitations, because in NC code we can just write the program in blocks, like 1 block, 2 block, 20 blocks, 10 blocks. So, gradually the things improve and the number of blocks can go up to maybe thousands or maybe more than that. So, that can help us to get a big program and to develop a very complex and large component or different parts of the components in one go. So, in CNC programming we go with part programming as well as the complete block program. In the part programming we generate code for the particular part, and the same code can be taken in a repeated mode to get the repeated cycles, and the complete body or complete product that is needed can be manufactured. In this way the stopping in between or checking the program in between becomes very easy. So, now what we need to have is a CAD model. The model that we have generated through any of the CAD softwares like SolidWorks, CATIA, Ideas or so, that can be brought into this program. So, this is the software Delcam Power Mill. This is a metric software. So, when we click here on the software we get this interface. So, here we can generate the code for the drawing that we have received. The drawing, when I say the drawing is the CAD, CAD is computer aided design. So, we can import the model for that. So, when I go to this drop down menu option import model. So, if I say import model, it will try to open the file. So, there are certain formats here, like we have IGS format, we have STP format, STL format. IGS and STP are generally used for the CAD or the computer aided manufacturing. In IGS and STP, the triangular mesh, that is the building blocks or the building, I would say building elements of the CAD, those are all separate. In this, when we have to use that on a CNC machine, it has to be taken care that Z should be always in the tool direction. Other format is STL format. In STL format, that is generally used for the additive manufacturing, because it generally consider the whole triangular mesh as one body. All triangles are kind of a merged in each other. So, it is generally used in 3D printing. So, STL and IGS or DXF, these are the common input files that can be taken in this. So, this is we have clicked here. So, it is importing the CAD model here. So, this is the CAD model where we will see how can we work. So, this is a simple IGS CAD model for which we like to generate a code. So, you can see here that the part programming and the particular area can be worked upon. For the terrain profile as well, the program can be made. So, basically numbers of machines are available for CNC and NC, like depending upon the profile or the geometry of the job that is to be made, If the job is cylindrical, obviously you know that we will use a lathe machine. The lathe machine, and there is one kind of lathe machine known as center lathe. In CNC technique, we have a machine with tailstock or without tailstock. A machine with tailstock or dead center is called as a center lathe. When there is no tailstock, we can call it as simple lathe. This is the difference between the center lathe and simple lathe. Similarly, in milling as well, the machining center or the milling machine is difference. So, this is the part that we are going to manufacture on simple 3-axis milling machine. So, generally when we say the classification of the milling machines, so 3-axis milling machine, 4-axis milling machine and 5-axis milling machines are there. In 3-axis milling machines, we have the x and y axis, that is the workpiece or the table that moves in x direction and in y direction, and tool is just that is moving in z direction. When the tool is also able to tilt itself, this becomes the 4th axis. For instance, there is a complex geometry. For instance, we have a mouse here. It can be manufactured while using this direction itself, or we like to tilt the tool and try to do some machining here, some deep machining here. This is 3 plus 1, 3 plus 1, that is 4-axis machine. In the 5-axis machine, what happens, this tool can also be tilted and the workpiece can also rotate to some extent, that is 3 plus 2, that is 5-axis machine. So, basically a machine should have 3 axes. So, what we will use is a 3-axis machine on which we will manufacture this component that we are showing here. So, this is the component. So, we can write the code for each and every corner, like this corner or any profile. We can write the code for each and every point here. Manually the code can be written, it is known as MDI, manual data input. Then there are number of faces here, you can see there is one face, other face. We can write the codes separately. So, here we can see the different features or outlooks for the workpiece that we have there. So, the software makes the task easy. It can create the code for all the points which are here. So, we can see that there is a circular profile, there is an angular profile here, there is a linear profile here. So, linear, this is linear x, linear y. So, when tool is going down, it is linear in z direction. So, whenever we generate the code with the help of any software, we need to take care of 3 things, 3 major things. Number 1, machine tool, number 2 is cutting tool, number 3 is the job where we need to work. So, whenever we generate the code, whenever we start the machining conventionally by hand or using CNC machine, we have to take care of these 3 major things, again machine tool, cutting tool and the job that is to be cut. So, the coordinates have to be set accordingly. So, that as the reference point for the machine tool, cutting tool and the job is same. So, this is one of the major concerns when we talk about the CNC machining, the reference point. What is the starting point that is put in software? What is the starting point where the tool touches the workpiece actually on the machine? So, we can define the block here. In the coding system, this is known as block define. When I go there, it will show block define. The term that is used is job reference or tool reference, that we will fix here. Actually, machine reference and tool reference is generally same. So, I will click here, it is showing the block form. It is clearly mentioned here that what we need to calculate here. It is calculating the x, y coordinates and z coordinate for this particular component. It is telling that the minimum x is 24.5, what is the reference that we need to decide. So, we can take this corner as the reference, this corner, or we can take this corner or this corner. Any of the corners can be taken as the reference point, that is the starting point, or we can take the center of the workpiece. Center would be the center of the x and the y direction both, and also the z means the perpendicular direction, the tool has to touch at the center of the workpiece. So, it is easy to take, or it is more convenient to take center of the machine, because that helps us a lot, because also this job is symmetrical in both directions, in or by x and y directions. It is better to take center. So, there are some jobs in which it is difficult to find corners. For example, this we cannot find any corners. So, this job is also a circular job. This can be manufactured in the machining center, that is the milling machine as well, and also on the lathe machine. But the center or the reference point for this job has to be the center. So, similarly, we can pick the center for the present job as well, that we are going to manufacture on the CNC machine. So, when we talk about the center or referencing, normally it is important to consider the reference between the tool to the job. That is, at what point does the tool touches the job, that has to be very well taken care of. So, I am again repeating that thing because this is very important point. See, this is the center of our model. So, this is 0 0. Now, we can see this is 0 0 of our workspace, let us say x y z 0 is here, and this is the corner of our block. So, we need to match this center here. So, what we can do, we can move the x, we are moving x to 0, we are moving y to 0, and we have also moved z to 0. Now, x 0, y 0, z 0 makes the center of our workspace, center actually origin of the workspace, and origin of the workspace and the corner is now matched. Now, there is one big problem here. What we can see here, this z is at the bottom, z has to be at the top, z has to be at the top, so as we are able to start the cut from top and then go bottom. Now, z, if when I see z minus 1, now when I put z as minus 1, you see when I put z minus 1, this reference has now, the origin point has come at the top. So, this corner is now the reference point. So, when the machining starts, this tool will start moving from this point, it move in x direction in this way, in y direction in this way, in z direction it also can move. Okay. Now, what if I need to bring it to the center of the workpiece? To bring it to the center of the workpiece, what I can do, I can take average of the values. Anyway, we could have taken any of the corners as also the reference, but just to pick the center of the job as the reference. So, we can move the x again, we have moving x to minus 20, because this value x total width for x is 40, x 20 would bring it to the center of the x dimension of the workpiece. So, it is in x center. For the y, it is 55.99. I need to take half of this value, half of this value would be divided by 2. This is this value, I will just copy this value and put it here for the y. So, now I have to put minus as well here. Now, it has brought the origin of the workspace, or I would say of the machine or of the software, to the center of the workpiece. Actually, better I would say of the software itself now. For the machine, we have to separately do it when we go to the machine. So, the software, now the center is at the center of the workpiece, we can see that when I rotate it, when I pan it. So, this is I can say that a safe Z for milling. So, I now I say accept, it is accepted, okay, saves the values entered, accept. So, this is locked now. Now, I need to save this job. So, I have created this folder. So, class 1, okay, they have created, I will save this folder here. This is the block that we would like to machine to create an NC code. Now, one of the important point is that I need to barricade the boundaries. So, this is the top surface of the job. So, these are work planes, these are work planes, we can create work planes. If I go click create work plane, so this work plane is created. You can see this small change, there is a very thin white line. Now the software knows that this is a work plane where it will start machining. Similarly, we can fix the boundaries, barricade the boundaries, that within these boundaries the tool will just be moving. So, it should not come out of the boundaries. This is the block that we have generated. So, for creating boundary, I will put the block. If I say block, so it will now, when I say accept, apply and accept, it will, you can see the thick white line. This white line indicates that this block is generated. Now, we can keep our tool inside the block, or maybe we can also define the tool to be kept outside the block. So, this is the boundary. So, whether inside and outside, that can be definitely chosen. So, now tool would never come out if we direct the software that the tool has to remain inside the block. Normally, when we generate the code, it is important that we need to take care of the movement of tool in xy direction as well as in z direction, because if anything goes wrong, the job will be definitely go bad, and also the tool can also go blunt. The tool can also break as well, and big accidents can also happen. So, it is very important to do or to run this simulation before going to the actual machining in CNC. While experience, definitely one develops in itself a prowess to work on the CNC machines on different kind of the setups. After that, one can definitely sometimes skip some simulation to see and go directly, but it is recommended to see the simulation or the animation of how the tool runs on the workpiece. So, we need to take care of the coordinates as well. Coordinates can be minus or plus in the negative or positive direction, but the tool would always do machining in the minus direction here. So, it is very important to be noted. Now, what are the tools here? So, the 3 points that I mentioned before, the machine tool, cutting tool and the job. So, let us talk about the cutting tool here. What are the options? So, we have an end mill tool here. To create an end mill tool, what is the purpose of end mill tool? It does the roughing. Major of the material is removed using end mill, then ball mill is generally used for finishing, then tip radius tool is there. So, this is also called bull nose, then tapered spherical tool. So, then we have tapered tip tools, then we have a drill tool, that is normal drilling is possible. This is tipped disc tool. So, this is normally used for cutting the walls or sides. So, this is an off center tip radius tool. There is some radius on the tip of the tool to bring more smoothness to the workpiece sometimes. So, ball nosed and tipped nose tools are generally used for finishing. So, for the purpose for which this is developed. So, this kind of profile, how can we do that? So, for this kind of profile, we will pick a end mill tool. So, when I click end mill, a few things are to be important to mention here. The diameter of the tool, diameter is 3 mm. Then if I pick diameter 3, by default it is picking the length as 15 mm. It is showing that minimum length required is 15 mm if you pick 3 mm dia to be held in the tooling center. So, we will held tool in the collet here. So, tool number is just the name of the tool. We can just name it like 3A, 3B, so on. I will just put tool number 3. So, I can even put tool in the name of the company or the job number or the job name. We can put any name in that, okay, tool number 3. So, now rapid move heights. Rapid move heights, what is the safe movement of Z? And starting off the Z here. Now, the tool is here at the center, the yellow color portion you can see the tool is here. So, the tool would interact and retract from the workpiece. When it interacts, what is the safe height? What is the start height? That has to be defined here. So, rapid move, what is the safe height? I have put 3 and 2. So, safe is 3. So, what does this reset to safe heights? Reset to safe heights, this implies that the tool would now start, tool will come in a rapid mode close to the center. It will hold itself at this position, that is 5 mm above the workpiece. This means that rapid move height would take the tool up to the 5 mm from the workpiece. So, it will then go down in 2 steps, in 3 mm and in 2 mm when the actual feed, cutting feed is given. So, this is a safe working height when the tool tries to enter the job from the top of the block. So, when sometimes the top surface is not flat or some roughness is there, like I just showed you the mouse, if it is having some surface, there has to be some safe height, and that is calculated, that is already evaluated before we start the machining. So, next is start point form. What is start point form here? So, where to start the machine? Block center safe Z or absolute or first point Z or first point. Absolute, it can just pick these coordinates 0, 0, 5. First point safe Z or block center Z. Block center safe Z. So, I can put 1 or 2 points here or just pick one of these options here. So, where would I like my tool to start from? That is safe Z head, that is already we have mentioned the safe Z height has 5 mm. I will put block center safe Z, because block center safe Z would definitely be the 5 mm, the value that is given, that is 5 mm. So, block center safe Z, I have picked it here and I will accept this option. Now, this from the center point to the tool, here we have tool, it is exactly aligned to the center of the job, it is just 5 mm above the job. So, the skim distance and the plunge distance. Now, tool path lead and links. What is skim distance and plunge distance? See this diagram here, the skim distance is 3 mm and plunge distance is 5 mm. There are certain ways the tool enters the workpiece. So, lead in and lead out. Lead in means when tool interacts with the job, lead out is when tool after machining comes out or retracts from the job. So, some extensions and links are also there. So, let us keep all these things default and try to put the Z heights, that is already given, already we have mentioned 3 mm and 5 mm. So, we have kept it is 5 mm above. So, the safe height that is kept is 5 mm from the center. So, this tool starts interacting with the job. Now, skim distance and plunge distance. Basically, skim distance means the tool is at 5 mm from the job, but it will go 3 mm in one step and then it will stop for some time, then it will go 2 mm further. So, plunging is actually the engaging distance. So, when the tool starts to get engaged with the job, that is known as plunging. So, the other methods as well that we will discuss. So, in this plunge it will go down. So, now tool axis direction form, we can see here the tool axis has to be vertical, lead lean, towards point, towards line, form line, fixed direction. These are actually different options in which we will like our tool to move. For instance, if we make some axis somewhere here, somewhere here, somewhere here, so somewhere here, here, like it out of the block, the tool will come here first and then it will start leading towards the workpiece. In this, we will make some corner or something, because this is normally a vertical milling machine that we are working on. So, I will keep this option as tool axis vertical. It is also a 3 axis milling machine. We do not have 3+1 or 3+2 options in the machine that we will work on. So, we will just pick 3 vertical. So, once everything is done, I am also keep saving my options what I am doing. So, next is work planes. So, we have defined the workplace, we have defined boundaries, we have picked one tool, that is 3 mm end mill cutter. Now, 2 important things are left, that is tool path and NC program. Now, we need to define the tool path next. After defining tool path, then we will focus on our final output, that is NC program. So, then we need to choose our strategy. We can go with the area clearance form, that what kind of area clearance we would like to have here. So, these are all options for the area clearance. So, before coming to area clearance again, I like to again repeat what I did. We picked the tool, we picked the end mill tool and we fixed the diameter as 3 and there are certain tool dimensions, so some cutting data is there, axial depth, radial depth, then feed speed, feed per revolution, anything that we need to just fix for our job or the specific kind of operation, we can lock it here. The feet per tooth, that is it depends upon the single edge, feet per tooth means the number of teeth those are there in the tool. It can be a double edge cutting tool, it can be a 3 edge cutting tool. So, it is in milling and milling there are flutes actually, double flute, 4 flute, 6 flute, generally 2 flute and 4 flute tools are used. Then okay, we can now select the feed rates. Now load from active tool. Active tool means when the tool is actually working, then the machining is happening, what is the load that tool gives to the workpiece, that values can be put here. So we fixed or we skipped the plunge icon, the plunge options before, because I will just put or fix that here. Now how the tool enters the job for machining. Rapid mode is when the tool is coming from the far distance close to the workpiece, it has to come close. Anyway, when we talk about machining, it is always the economics of machining that also comes into the play. We have to get our machining done to, number one factor is quality. The quality has to be there, that is why some roughing or the rough cut is there. After the rough cut, we do the major cuts, or those are known as the finishing cuts. So, they are rough cuts, then we have rastering, then we have finishing cuts. So, also economics of machines is also there. We cannot just put more time to machine, whatever could be done in less time. We have always to optimize the time that is there for machining. For instance, if we use rapid speed, from the far off distance, the tool can come closer to the workpiece in the rapid speed, then it can start machining. So, this rapid speed would save time. So, this is also very important. So, we need to put some values here. The rapid is the speed, that these many units per minute, this is the speed. So, how rapidly would it come close to the block and start machining. So, rapid it is 3000 per minute, and plunging is actually the final machining. When I say final machining, it has to be the feed rate that is selected for the specific combination of the tool and the workpiece. For instance, we can just use the chrome plated tool for the mild steel. So, there is specific combination of tools. Some materials are very hard, like titanium is too hard. For the titanium we have specific set of the feed rates, specific set of the plunge rates as well. So, this plunge is the final machining that has to be selected very carefully. There are handbooks available for this, that what is the feed rate, and whenever we buy tools, there are handbooks for the tools as well. For this tool, manufacturers, they provide for our tools, these are the feed rates or the speeds that you should use for machining. So, those are to be put here. The plunge value that is put here is 50, that is a small value. So, when it is, because plunge is something when tool is trying to enter the workpiece, when it is trying to enter the workpiece, it has to be a little slower, so as there is no harm, there is no distortion to the tool or to the workpiece. So, finally, once the plunge happens, now the cutting units are 800, that is put. Now, next is spindle speed. Spindle speed is in RPM, rotations per minute, that is the value that is put here is 1500 per minute. Okay, to again clear the things, the rapid, plunge and cutting are the feed rates, and spindle speed is actually the speed. When I say rapid, plunge or cutting, these are feed rates, 3000 units per minute, 50 per minute, 800 per minute, this is the feed rate. So, now again let us see the rapid move heights form. So, rapid move type form scheme. These are rapid units. So, after cutting, tool will interact to the job, that is go towards the job. Now, it will start moving to the next point, and it will start moving in these speeds or these units or these feeds, those are put here. So, reset to save ites again, just to see it will remain itself 5 mm above the surface. So, it will go in 2 steps, that is 3 mm and 2 mm. So, rapid move type is skim here. So, let me accept everything. Again block center save set already set this skip distance. So, I am rechecking everything because I need to put this information to the machine finally. Okay, this is done. This is vertically again accepted. Okay, everything. Now, let us come back to the area clearance form. See, there are 3 options: raster, offset and profile. So, we have to clear the area in various ways. This is the area that is to be cleared. Now, how would it clear the area? There are certain modes for the raster that can be selected. So, this is in raster is actually one thing that matters, MRR, material removal rate, that how fast we can remove the material, and also while keeping it fast we need to maintain the quality, and one important factor is also the tool life. We cannot move it very fast and affect the tool life. That is also one of the important factors to be considered. So, also this is pocket machining. Pocket machining, like this is a circular pocket, this is a rectangular pocket, or these are linear pockets here. So, when the repetition of the certain pockets are there, then pocket, it will actually by itself pick whether they are pockets or not. We can check it or uncheck it. So, machine areas pocket by pocket it can do. So, there are certain ways to do machining. So, thickness can be put here. So, whenever the pocket machining is needed, the software is intelligent enough to identify that the pockets are there, and will pick that. Now, step down. What is step down? Step down is kept as 5, the maximum distance to allow in z direction. So, I am putting it 0.1, okay, 1 mm actually the distance finally. So, now plunging, ramping and drilling, these are lead in moves. I just mentioned the lead in moves. Now, what are these lead in moves? Plunging, ramping and drilling. There are 3 ways the tool can enter the workpiece. So, this is important to understand. How does the tool goes to the workpiece? So, when the tool goes down, let us say there are 3 options. Number 1 is, I would say, plunging. Number 2 is drilling. Number 3 is ramping. So, plunging is, suppose this is our workpiece and this is our tool, an end mill cutter. Plunging is, it just comes down to this length. Suppose if I say height is, this height is 3 mm, and the second plunge length I would say is 2 mm. It will just come up to this height and then this height, it will just come in one direction. This is plunging. What happens in drilling? It will just have the reciprocating movements in up and down directions, up and down directions. So, it will come down and go up. Now, in drill what we have the tip here. So, in tip we have some angle, this is known as lip angle or tip angle. So, drill comes, it comes down and goes up. In the second step it again comes down, then goes up. Okay, this is one. Then this is on the second step it comes. So this is first step, this is second step, it comes to this direction. In the third step it might come down and make a through hole. This is step 1, this is step 2, and I would put this is step 3. This is drilling. What is ramping? As we know what is ramp? Ramp is a wedge kind of a shape. So, in this tool can move in z direction, it can move in x direction, and it can also move in z and y direction, z and x direction together, z plus x direction. So, what happens, suppose this is the workpiece and we have a tool here and we need to cut something like this. We need to cut here. So, it is like the landing of the aeroplane. It will move in this direction, both z and x direction are working, move in this direction and make its cut. So, it is ramping, it is moving in this direction. So, this is known as ramping. There are three ways how the tool can enter the workpiece. So, these can be selected in the software itself. So, these are the ways the tool slowly approaches the workpiece or interacts with the workpiece and reaches the maximum depth of cut that is there. So, I am selected plunging here. So, the thickness, okay, let me select the thickness 0.1 and show you how does it conclude, how does it evaluate. Now, you can see it is showing the plunging here. What is plunging here? You can see the red and the blue lines. What is the red line? Red line is the first step of the plunging, blue line is the second step of the plunging. The first distance, the red line distance is 3 mm and the blue distance is, so this is the tool, it is going to plunge inside. So, how the tool leads in or leads out? So, I am going to click here. So, it is showing me sequence command given command step simulation, each step it will show. Now, I will click on the next step is this, next step, next. So, it is command wise, it is leading in and coming out. So, once it has done the machining or some of its operation here, it will come back to the safe height, that is 5 mm. So, it is going in 2 steps. So, it is coming back, okay, because it is rapid mode, it is come 1, 3 mm, 2 mm again. See it again carefully. So, it is 5 mm above in rapid mode, now 3 mm down and 2 mm down in 2 steps. So, now in the rapid mode. So, now the complete simulation, I just press the play button and the complete simulation. So, with this command system, we can get the complete code of the whole job. It is just the plunging. Where does the plunging happens? When we fix the fixed coordinates, you can see this pattern, the pattern that is built here on the workpiece. In this pattern, at each corner, whenever the tool turns, the plunge happens. The tool comes down or comes out. So, that is being shown in this simulation. So, lead in and lead out is being shown here. So, see the simulation again, stepwise 1, 2, safe height is 5 mm, tool reference 3, now 3 mm and 2 mm, yes, now it has entered. Now, it is machining, then lift it up, lead out, then lead in, then lead out and so on, complete machining again. Okay, complete machining, complete plunging action. So, we can also stage this strategy. Let me say, so I had actually what I did, I had just put the thickness as 0.1 mm. Now, let me try to change the thickness as 0 and we can see this, what is this showing, that it is just 3 mm, 5 mm, this is just tool profile, tool movement in a rapid mode. So, this is just important to see, because in case the operator or the coder who is trying to code or trying to put the values manually, he might forget to put some minus sign, he might forget to put some value properly, there might be some accident. So, that is important to see that how the rapid movement happening. So, rapid movement always has to happen outside the workpiece area. So, that is important to see. So, again let us see this rapid position 1, 2, 3, lead in, okay. Now, this is the complete machining. 100%. So, again repeat complete machining. So, in this way the tool removes the area. So, this thin tool responsible for removing the material. So, that is why it is known as area clearance. Now, area clearance is happening. For each block the area clearance, for each block the area clearance would happen. So, it is clearing the area step by step, you can see. See, for the whole area it is now cleaned. So, this is the complete simulation of the machining. This is the final workpiece that we will get. So, this is the roughing. So, profiling is also one of the options. When we set profile here, so how does profiling happens? When I say profile, it will machine in this way. You can see it will start from one point. It is just making a linear movement. This is known as profile or profiling. Okay. In one go, it has completely machined. So, it is not taking care of the what is getting out, the stock, that is stock or the block, this round stock, that is the waste material that will come out, is not taking care of that. It just do the profile, just make the profile. So, roughing, profiling and finishing, the three modes. So, let us see different modes here. So, strategies, different strategies for finishing form. For finishing form, you can see here there are certain strategies. There is raster, radial, spiral, pattern, constant Z, then optimized constant Z, rotary, 3D offset, pencil, multi pencil. What are these? Let us try to see. There are numerous types of profiles that can be taken here. So, like what is raster? It is just doing the entire area. Radial, it is just taking off the corners of the radius. So, fine spiral, it is just taking care of the top surface in a spiral mode. These are all rastering patterns actually. So, pattern, it is making a pattern the small area, then constant Z, it is making the Z value feet constant from the top to bottom, it is coming down. In a circular ring pattern, it is one of the ways it is doing. Then comes rotary. Rotary is all around the job that is there, job of the workpiece that is there. Okay, what is 3 offset? 3 offset, it is just for the top profile. Then pencil is just for the corners, actually the edges of the workpiece. There are sharp edges there. So, those edges are now worked on using this pencil command. So, in manufacturing, it is generally for some fillet radius or something, some fillets are there. So, for which are not required, when sharp corners are required, then pencil command is used. Then multi pencil is also for removing the corners. And stitch corner is making the vertical and the horizontal surface 90° to each other, at right angle to each other. So, rear stitch service, and along corner again there is a circular mode is here. So, it can cure our corners and yes, surface projection. Yes, this is important. Now, what is there? You can see the tool in 2 directions here. Here the tool is in horizontal direction and the tool is also in vertical direction. So, this is surface projection. How does surface projection happen? This can only happen when we have at least 3 plus 1 axis machine. So, this is a kind of a free form surface. So, with 4 axis or 5 axis system is there. So, this is vertical tool, this is horizontal tool. So, this is automatic corner. Okay, line projection. For instance, we have some impression of a bottle here. So, some small impressions are to be made there. So, this is a half bottle here, then line projection is used for this thing. Small line materials are moved here. So, this and then swath is there, it can move in a profile in a different mode. So, there are different modes for the finishing. So, there are certain ways, again radial, raster. So, the depending on the part, where the part has to be matched with other part, putting the right tolerances, we have to machine it accordingly, selecting this finishing form. This is all the again skill of the operator or the user who is selecting the forms here, the different strategies here to a machine to make the proper match, whether the fit is a push fit, whether the fit is a loose fit or tight fit, all that also depends when the surfaces are matching. So, minimum step down, that can also be set here, it is, let me say it is 0.1. So, boundary is already mentioned, sharp corners, okay, corner selected, corrections are sharp, direction is climb conventional or any, let me put conventional. So, boundary trimming, yes, this is important. What is boundary trimming? We have already selected the block here, this block form is there. To which direction or to which side of the block we need to keep? While see, I will put it keep inside. If I put keep inside, it will keep the tool inside the block. If it say keep outside, it will keep the tool outside the block. So, this is to be selected properly. A boundary, when we say boundary, boundary barricades are there, it has to remain inside those barricades. So, this is finishing form. So, it is choosing its path my own and trying to finish the form, which is taking care of the finishing of the workpiece. So, in this way we generate the tool path. It is how tool will move, how the tool interacts, how the tool retracts. So, we can also name our different tool paths, like I have just put it different name for that, so that we can recall the data whenever we like. So, we can also store the same program somewhere and try to redo this program multiple times, and also, okay, let me put the output file, in which form would I like to get the program. See, there are certain options here, you can see this, there is FANUC, there is head and head, there are certain different kinds of formats, there hundreds of controls are available in the market nowadays for different types of machines. So, like Dyna, FIDA, Hedden, then Mazak, Metsura, so many over there. So, let me select which is suitable for my machine. This actually PowerMill is a general software that can be used on many types of the control systems. So, for our machine, let me say I will pick a FANUC control. So, now this is the program, this is a long program that is generated. So, it would be very difficult to generate big programs like these manually. However, there are certain say redundant or unwanted commands here. So, okay, what does this percentage signifies? Definitely signifies that this is a FANUC. So, when I say FANUC system has code written in a 4-digit number, 4 name. It is like in 0001 here, it will always be 4 digit, okay, we can put it maybe 9999 or so, or maybe 1111 or 1234, but the FANUC system always has the code in 4 digits, that is the program number, alphabet O and 4 digits, this is the FANUC, alphabet O and 1234 any 4 digits. So, N20, 30, 40, 60, these are all sequences, these are names, block sequences are there. So, it is G91, G28, X0, Y0, Z0. So, G91 is generally first line, then we have G40, G17, G80, G49. So, already you know what are G codes, what are the meaning of these codes. So, you can write your own code as well. G00 is actually rapid code, Z5 is the safe Z value. So, then T3M6, okay, what is T3M6? T3M6, as you know there are certain codes G and M codes, G are the general codes, M are the miscellaneous codes, G54 is the tool reference. So, you already know applications and the meaning of these codes, and tool rotation is important, the certain codes are there. Okay, tool cutting moves, thickness, tolerances. So, already raster roughing is the first operation that is going to happen here. So, these are a few things just mentioned by the software. These are not the part of the machining, just mentioned that these are the parameters which are set in the software for the machining. The time is also mentioned here. That is 57 minutes 42 seconds would be taken for this thing, and number of lifts that would happen would be 1111. So, to perform this machining, this much effort, time, all those things would be taken. So, this is S value. What is S? S 1500 is speed, 1500 RPM. M3 is the rotation clockwise. If we change M4, it is rotation anti-clockwise. The tool has to be rotated clockwise here. So, that is M3 is kept here. So, when we start writing code G or M code in a Fanuc system, two things are very important. Obviously, you know that G and M. G is preparatory code, M is the miscellaneous code. We can also see, okay, G is cutting mode in x direction, we can see value 1.5 y minus 1 and z is okay. F, what is F? F is for feed. The feed is again 3000 here. 3000 means it will be rapid. If you remember, we have to put 3000 as a very rapid feed. Now, G0 is again in rapid mode. So, Z 1.909. So, this is lead in or plunging in. So, G1 Z minus 0.182 and F50. F50 means now the plunging is happening. Feed value is 50 here. Now, the tool is entering the job. That is the machining has started here. Now, the speed is 1500 RPM and feed is 50 mm. Now, once it has plunged in, the next command makes the feed to 800 that was set there. Oh, this is cutting mode. The cutting feed is 800 millimeters per minute. So, this is plunging feed, cutting feed and rapid feed. So, these are the movements of the tool. So, these are three different feeds and yeah, this is the whole code that is written here. So, let us see the closing commands here. It will do all the operations. Then we have M9. M9 means it will shut off the cutting fluid. Then G91, G28, Z0. G91, G28, Z0. So, it will put Z at value 0. So, now G28 X0 Y0. So, in the milling it is very important to note that we need to put our X, Y and Z values to 0 first, then M30. M30 is end the program. M30 is program end, that is all. So, all the commands gets switched off when we put M30 there. Okay, some commands are taken in absolute and some in incremental mode here. So, because it is generated by the software itself, it has to get the work done, get the job manufactured or fabricated. So, it has taken its own intelligence to develop the commands accordingly. So, there are certain things which are not required, like these are just the information. Okay, I can just take this off, all these are not required, this is also not required. So, there are certain conditions in which the program is written by the software, it has its intelligence and also certain limitations are there. So, those sometimes are to be taken care of for the specific machines. The operator might have to put its own values to keep the reference at the proper alignment, or maybe some other tool value to select the tool. There are certain things those are to be taken care of. And for instance, if you have taken a Fanuc program and we are trying to put it on a different machine, we have selected the program, we have made the program for a specific kind of machine, and the same program is to be exported to another kind of machine. For that kind of machine, different kind of setup in the beginning and at the end, different commands are put. However, the machining, the major operations would be remaining same most of the time. So, these are the major things. Now, this was all about the Power Mill software. Now, in the next lecture, I will take you to the 3-axis milling machine, where we will use this code that we have generated here, this component or the profiling that we have seen, the specific pattern that we have seen in the software, we will try to produce that there. So, what are the points or tips to be noted while we go on machine, while we work on machine, that I will discuss in the next lecture. Thank you.